Greetings all! I hope you guys are staying safe and keeping well. In today's video we will tackle the first question in November 2019's paper 1. You can find the link to the paper down in the description. So without any further ado, let us get into the math. So 1.1.1 is actually a quadratic equation, and lucky for us we have a formula in order to solve this, and that formula is at the back of your paper. It's labeled in the information sheet, and I'll tell you a little bit later what the formula looks like. But we can first start by rewriting the question, which is x squared plus 5x minus 6 is equal to 0. Then I'm going to actually write out the formula quickly. So that is your quadratic formula, and we need to figure out what these a's, these b's, and these c's stand for. And these a's, b's, and c's are actually the coefficients to each of our x terms and our constant. So your a is going to be equal to, well, what is our coefficient of our x squared term? It is 1. B is equal to, well, it is a positive 5 next to the next x term, so our b coefficient, or our b value, is equal to 5. And then lastly we have c, and our c is a negative 6. It's very important to note that is negative, because if you put in a positive you'll get a very different answer. So c is negative 6, and that is all over 2 times a, which is 2 times 1. We don't really need to do anything more here but plug this into our calculator. Now please note that there is a plus minus symbol over here. All we need to do is plug this into our calculator, and you might be wondering, this symbol is not on my calculator. Where do I get it? Well, it's actually two different answers that you're going to be getting. The one where you use the plus and the other one where you use the minus. So for example, the plus one is going to be negative 5 plus your square root value, whatever's there, over your 2a, and your minus value is going to be negative 5 minus your square root value, and what is all over there, over 2a. And the answers you should get in the end should be x is equal to 6 and x is equal to negative 1. So if you plug that into your calculator, you should get those two values. There is a shorter way to do this, but it is a bit more difficult. I'm going to show you a small piece of the solution without too much commentary. But first let me just make some space. So the method I'll be showing you is called factorizing, and we'll be factorizing this equation to make it look like this. And if we factorize and we make this equation this expression the sum of two terms, we will get x and x. And there are going to be no coefficients behind these x's, because this coefficient next to the x squared value is 1. And then we are going to have two terms, or two values, that multiply to make negative 6. So there's going to be a plus and a minus over there. And what are our two values going to be? Well, they need to be, again, two values that multiply and make negative 6, and also numbers when you add them up together make positive 5. Well, those numbers are 6 and 1. And just remember, those aren't your answers. Your answers are, what do I need to make x in order for each of my terms to be 0, or for one of my terms to be 0. So for this term over here, what do I need to make x in order for this to be 0? Well, I need it to be negative 6. And what do I need it to be 0 over here? Well, I need it to be 1. And you can see that these answers are the same as the answers we got earlier with our quadratic formula. Okay, let's move on to 1.1.2. 1.1.2 is also a quadratic equation. We can follow the same steps we did in the first question. So let me write out the question. It is 4x squared plus 3x minus 5 is equal to 0. And then we can rewrite our quadratic equation just one more time. And now we just need to think about what a, b, and c are equal to. So a is equal to 4, because 4 is the coefficient behind the x squared variable, so that's going to be 4. B is going to be positive 3, because that is the value behind the x variable. And c is going to be negative 5, because negative 5 is the value of the constant. From here we just need to plug this into our equation, where x is going to be equal to negative b. So what is b? B is actually equal to 3 plus minus the square root of b squared, which is 3 squared, minus 4 times a, which is 4, times c is negative 5, and this is all over 2 times a, which is 4. So like the first question, you are going to have two different answers because of this plus minus sign over there, and you're going to have a answer for when you take the positive, and you'll have a answer for when you take the negative. And I'm not going to go over this because you just need to put this into your calculator, but these values are x is equal to negative 1.55, and the other one is x is equal to 0.80. And just remember that they ask you to give it to 2 decimal places, so please make sure that you do that. Cool. So let's move on to question 1.1.3. The question 1.1.3 is a really fun question to actually do because there are a couple of steps that you just need to follow in order to get this question correct, and I'll show you them right now. So firstly, you need to think about this expression or equation over here as an equation and think about it on a graph. So let's just write y is equal to 4x squared minus 1, and now think to yourself, what does this look like on a graph? Okay, so now we have our x-axis and our y-axis, and now we need to plot this graph on it. But where is this graph going to go? We know that all quadratic functions have a similar shape, so they all look something like that, or they would look like that. If your x squared coefficient is negative, it would look upside down, or if it is positive, then it would look like this, and then it would just go all the way up, all the way to infinity, and if it is negative, it would go all the way down. And just by looking at this equation over here, you can see that our coefficient for our x squared term is actually 4, and it's not negative 4, it's 4, so our graph is going to be pointing upwards like this. So now that we know that, we need to figure out where on this graph does it go over here, or does it maybe go all together on this side, or where are these points that we need to figure out where these points are over here. What are these values over here? And the reason we need to find that out is because on our y-axis, this is 0. This point over here on our y-axis is 0. And everything above this point is going to be considered as greater than 0, and everything below this point is going to be smaller than 0. And we are going to use that to find out what is this bottom part of the graph, or where between which two values does the graph go down below 0. Okay, let's do that quickly. And the way that we figure out what our two values need to be is by using either the quadratic formula, which I showed how to use you guys how to use in the first two questions, or you can factorize. And for this question, I'm just going to quickly factorize, not explaining too much, but you can check the previous questions if you want to know how to use the quadratic formula to find out what our x-intercepts are, because that's what we are looking for. We are looking for two x-intercepts. This is our x-axis, and we are looking for the place where our graph intersects our x-axis. And we are going to get y is equal to 2x plus 1, 2x minus 1. And over here, we need to find out where it intersects y at 0. So y is going to be equal to 0, and we can say that 0 is equal to 2x plus 1 times 2x minus 1. And we will then find that over here, in order for this term to be 0, x needs to be negative 1 over 2, and over here, x needs to equal to 1 over 2. And now we know what our intercepts are. We know that our intercept, our graph, is actually needs to be shifted a bit further this way, but regardless, our intercepts are going to be at negative 1 over 2 and 1 over 2. And if we just read our question again, our question says 4x squared minus 1 is smaller than 0. So where on this graph is it smaller than 0? Well, this is the y-axis, and the y-axis is 0 at the x-axis. That means everything that I'm coloring in pink over here are x values that are smaller than 1. So how do we state this in an interval form? Well, it's all the numbers of x, it's this pink section over here, all the numbers of x that are between negative 1 and negative 2. And our answer, just write answer so that we know that this is what we are looking for. Our answer is negative 1 over 2. And we're going to have x 1 over 2. So this states in English, it would say x is greater than negative 1 over 2 and it is smaller than 1 over 2. And you can do this for any quadratic equation that you are trying, or quadratic inequality that you are trying to solve, where you just draw out the graph. You see what the graph looks like, and then you shade in the part that you want, and then you look at the x-axis to see, you figure out your x-intercepts to see what the interval it is you want. So for 1.1.4, I just wrote it out so that it didn't take too much of our time. 1.1.4, you're just going to need to algebraically manipulate this equation until you get something that you want. So the first thing that we're going to do is we're going to square through all the terms, and if we had to square through all the terms, so what we're going to do is we're going to square that, we're going to square that, and because these two terms are multiplied with each other, we square them independently. We're not adding them together, we are multiplying them together, the product of two terms. So each gets squared independently. And if you square each of these terms, square root will go away. Let's square all the way through. And what we would get is x squared. Over here you would have the square root of 32 minus x. Without the big square root over it, because we squared all the way through. And over here we have the square root of 32 plus x. And if we multiply this through like we would normally, you will get the difference of squares. So what I mean by difference of squares is if you multiply this through like that, and then you multiply this through like that, you will get square root of 32 squared minus x squared. So you can try that for yourself and you'll definitely come to the right answer. And you will get 32, which is square root of 32 squared minus x squared is equal to x squared. And then we are going to take this x and we're going to take it over to that side. And when we take it over to that side, this is going to become 2x squared is equal to 32. We're going to divide by 2 on both sides, and we are going to get 16 is equal to x squared. And lastly, we are going to take the square root on both sides, and we're going to say x is equal to plus minus 4. And why do we say plus minus 4? Because if you square root any number, any value, you get the positive and the negative. And now before we take that as our answer, whenever you see square roots in the question, you just need to remember that if you have a square root function, everything within the square root function needs to be greater than 0, and everything that comes out of the square root function will be therefore greater than 0, and that should make sense. So if we have an x over here that is the sum of two square root functions, these are two square root functions, both square root functions need to be greater than 0, and if both square root functions are greater than 0, this x value has to be greater than 0. So this answer over here needs to negate negative 4 as an answer, and your answer should actually only be x is equal to 4. Now it's very difficult to spot this, but whenever you have a answer that is the plus minus of any equation, if it's plus minus 4, plus minus 1, plus minus 2, just double check the initial equation to make sure that it makes sense, or just plug the values in and see if it makes sense into your calculator even, because if it doesn't make sense, then you have to take away one of those like we did right now. So these are the two equations that they give us for 1.2, and we need to solve for x and y. Of course, a simultaneous equation. So the first thing you want to do in a simultaneous equation is choose the less complicated equation and isolate one of the variables. And I'm going to isolate y just because I want to. I mean, you can isolate x if you want to, but I'm going to isolate y. So over here we have y plus x is equal to 12, and I'm going to take the x all the way to the other side. So this will become y is equal to 12 minus x. Okay, and if you look at our other equation, says y is equal to 14 minus x, and all now I need to do is I need to substitute this y over here for the equation that we made on this side. So because y is equal to 12 minus x, I can rewrite it in this one. So it's going to be x times 12 minus x is equal to 14 minus x. Again, this just to reiterate what I did over there, we noticed over here that y is equal to 12 minus x. Here is a y, therefore the 12 minus x goes where it was. Okay, so let's carry on. And the rest is just multiplying this bracket out, which is going to go like that and then like that. So you will be left with 12x minus x squared, and that is all equal to 14 minus x. And I like to always have my x squared coefficient to be positive. So what I'm going to do is I'm going to take this 12x and this x squared to that side, and then we can maybe make it work. And we're going to leave on this side 0. And we are going to be left with a quadratic equation. So I'll be left with x squared. If I'm minus 12 on this side, I'll have 0x. If I'm minus 12 on this side, I'll have a negative 13x. And lastly, I'll have plus 14. And now, finally, we just use the quadratic equation like we did in the other previous examples, and we solve for x. So let me write down that equation quickly. So that's our quadratic formula, and now we just need to figure out what a, b, and c are, and then we can just plug that into our calculator to get our two results. And again, I did this in the previous question. We're going to get two results because of this plus minus sign. The one result is going to be for positive and the other one's going to be for negative. So just to write out what our A, our B, and our C is. Our A is going to be 1 because there's an imaginary 1 over there. So A is going to be 1, B is going to be negative 13, and C is going to be 14. And now we just plug these values into our equation, and again, you're going to get two values. You're going to get one where you consider the positive and one when you consider the negative. And the answer for when you consider the positive is going to be x is equal to 14, and when you consider the negative, x is going to be equal to 1. Just don't forget that you are not only looking for the x values, you are looking for the y values as well. And in order to find our y values, you need to substitute these x values into our equation on top over there. So you're going to plug that 14 into over there, and you're going to plug this 1 in there as well, and you're going to solve for y. And when you solve for y, I'm not going to go over that because that's pretty simple, but when you solve for y, you are going to get y is equal to negative 2 when x is equal to 14, and for the other one you are going to get y is equal to 11 when x is equal to 1. So for the last question, 1.3, we have a product, and this product is equal to 1 times 2 times 3 times 4 all the way to times 29 times 30. And then we need to find the largest value for k, or we have to determine the largest value for k, such that 3 to the power of k is a factor of 30 factorial. Oh, sorry, this is actually equal to 30 factorial. I just wrote that for short. This is just another way of writing this product. Okay, so what do we do here? Or what do we need to think about? In order for 3 to the power of k to be a factor of anything, that means that this product over here, when you divide this product by 3 to the power of k, then you're going to have a whole number. So let's just think about the first couple of terms. Let's just say 1 times 2 times 3 divided by 3 to the power of k. And let's think about what's the largest value k can be in order for this, for 3 to the power of k to be a factor of just 1 times 2 times 3. And you might say, okay, well, that's obvious. It's 1 times 2 times 3, and it can't be 2 because 3 to the power of 2, that would be 1 times 2 times 3 all over 3 times 3. And then you would have to cross these two out, and you'd be left over with 1 times 2 over 3, and this is not a whole number, okay? And if we start all over, we can consider 1 times 2 times 3 over 3 to the power of 1, which is just 3, and we can then cross these guys out, and you'll have 1 times 2 over 1, which is equal to 2, and that is a whole number. Now we need to figure out how many times these 3's are represented in this long product, the 30 factorial, or as 1 times 2 times 3 times 4 times 5 times 5, all the way to 30. We need to consider how many times 3 is repeated in it, and we're going to prime factorize all of the numbers to see where 3's exist. So we're just going to prime factorize the multiples of 3, because if you take 7 for example, or 8, or 10, none of these have 3 in it. 7 is a prime number on its own. This is going to be 2 times 2 times 2, and 10 is going to be 5 times 2. You can see that obviously this is not going to represent, or not going to have any 3's within it. We need to only use the numbers that are going to have 3's within it, and those are all the multiples of 3. So I'm going to clear the board, and I'm going to write out all the multiples of 3, and then I'm going to prime factorize each one of them, and lastly I'm going to count the number of 3's that exist to find out what the largest value of k can be. So these are all the multiples of 3 between 1 and 30, because these are the only ones that we are considering. And you can actually picture a multiplication signs between all of these, because we're taking the entire product, but we're only going to consider these guys. And there are actually multiplication signs between all of these. So let's prime factorize 3, and that's going to be 3. 6 is going to be 3 times 2. 9 is going to be 3 times 3. 12 is going to be 3 times 2 times 2. 15 is going to be 3 times 5. 18 is going to be 3 times 3 times 2. And you can see how easy this actually is, or how you can do this very quickly. Sometimes you might get to a question and it might take too long to write all of this out. It actually isn't that long, as you can see. It doesn't take that long at all. You just need to do it. That'll be 3 times 3 times 3. And lastly, that is 3 times 10. Okay, so now all we need to do is count the number of 3's, and then we can find our k value. So that's your first 3. That's 1, that's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And therefore k is equal to 14. You can write this as 3 squared. You can write 3 squared over here as well. It just makes things a bit easier for you to count. And over here it's obviously going to be 3 to the power 3. But all of these will add up. And obviously the 3 alone would be 3 to the power 1. And if you add up all these powers together, you're going to get your value of k.